This is a time series forecast for U.S. firearm deaths for the years 1999 to 2014. This is for UMUC Data 620, Summer 2017, Assignment 9.1 for Professor Carrie Bean. This presentation is created and presented by me, Erin Cruzet. Let's start with a quick background on why I chose this topic. As you're no doubt aware, there's been widespread media coverage of mass shootings in the U.S. in recent years, particularly since the Columbine High School massacre in 1999. The U.S. has more guns per capita than any other country in the world, and almost twice that of the second leading country. But is the firearm-related death rate in the U.S. increasing over time?
Let's take a look at our first story point, a time series of U.S. firearm deaths per 100,000 people from 1999 to 2014. The dark blue solid line shows that the firearm death rate has been fluctuating up and down between a minimum of 10.1 in the year 2004 up to about 10.7 in the year 2012. The dark blue dashed line is an 8th degree polynomial trend line, which I chose because it had the best fit of the available options, although r squared is just 0.4. This explains why Tableau's forecast is a flat line at 10.52, with wide confidence intervals for the years 2015 to 2018. There's no real clear trend here. However, since both the local 5-year minimum and maximum have been increasing in the last 5 years, I think what we're actually seeing is just the beginning of an upward trend here. In our second story point, we have a time series of U.S. homicide rates per 100,000 people. At the top in orange, we have all homicides, and at the bottom in green, just gun homicides. Both show the very same pattern of rising until reaching a maximum in 2006 and then decreasing. Again, the dark dashed lines are polynomial trend lines. Interestingly, Tableau predicts that the overall homicide rate will continue to lower while the gun homicide rate remains constant at 3.52. This makes sense given that the gun homicide rate has been decreasing at a slower rate than overall homicide, but I don't think that these two measures would suddenly begin behaving differently from each other. So I actually think that they are both going to continue to go down, just at a slower rate for gun homicide. Our next story point shows U.S. suicide rates per 100,000 people. The top line in yellow shows all suicides, and the bottom line in blue is just gun suicides. From this visualization, we see that both gun and overall suicides are increasing in the U.S. since 1999. Tableau forecasts that both will continue to rise, and I agree. The confidence intervals are small relative to the rates themselves, and these both look like clear upward trends. Our final time series shows the number of firearms produced per year per 100,000 people of the U.S. population. We see a clear increasing trend at an increasingly alarming rate from 2004 up to 2014. If U.S. firearm manufacture keeps pace with the last 10 years, then we will produce over 7,000 guns per 100,000 people this year in 2017. This is nearly 5 times what it was just 18 years ago. Our final story point shows year-over-year percent change in gun death rate and median personal income. You'll notice that the colors in the legends for the two measures are reversed. This is so that when the two bars are overlaid, we see a single colored bar on the years where gun death rate and median personal income change in opposite directions, and we see a two-colored bar when they are changing in the same direction. This helps us to see that there are only 3 years when gun death rate and median personal income are changing in the same direction, and that would be 2004, 2005, and 2009. While we can't infer causation, It does appear that gun-related deaths tend to increase as personal income decreases and vice versa.
I hope you found this presentation to be interesting. Have a great day.